Hey, Campbell. How are you? Oh, buddy, I'm so sorry. Momo's sick too. Oh, I hate that for you. Were you sick all weekend? Oh, oh, wow. Are you feel any better today? Oh, good. I'm glad to hear that. Glad to hear that you're on the mend because some people are hanging with this stuff for a long time. Oh, I really do hate that. Did you? I can't remember. Did you finish on Friday in class? I feel like you did. I've been out of town all weekend, so I haven't. I can't. I can't. I haven't even looked to see which ones, who turned them in. I'm getting up to get my folder now. These are the quizzes. Hang on.
I have yours. I see it. Took me a minute to get to it, but I see it. I just haven't graded it yet. I got to grade that, and then also the quiz from the book. So, and I just noticed, unfortunately, I posted the video just a few minutes ago, because I had forgotten that I was trying to find a shorter video. It's not a lot shorter, but it's 3 minutes shorter. But I was trying to find a shorter video. The other video was like 12 or 13 minutes, and I think I got this down to, I don't know, 8 or 9 minutes on this new section that we're doing. Did you have questions? Or do you want me to just go over and review what we did? Or do you want me to go through some samples of the new stuff? Oh, I could just do the guided practice problems with you so they would be done. Or do you, okay. I was going to say, do you feel well enough to do that? I don't want to make you. Oh, okay. All right. Well, I'm going to get some notebook paper out and pull them up. Also, wish this erased a little better than it does. There we go. Slowly but surely, it's cleaning off. Okay. I'm going to try something else too. All right. 4x minus 3y. I was going to try and cut and paste this. Not working. Okay, so the first problem is 4x minus 3y equals 5. And the second, but this is the first problem, second equation of the first problem is negative 2x plus 3y equals negative 7. Okay. This section is called solving linear equations by elimination, by adding or subtracting. So it's kind of wordy, but there's an overall title to this because we're going to learn how to do it by multiplying as well. So this part is just by adding and subtracting. 6.4 is by multiplying. But the whole thing, the whole concept itself is called solving linear equations by elimination. And let me just make sure you're not asking me a question. Let me switch back. Let's see. I just want to make sure. I'm just switching back and forth just to see if you have a question, because I can't really see that if you ask a question. So making sure you're with me. All right. So on this, the most important thing is to make sure, the very first step is to make sure both of the equations are in the same form. So like, you know what, by that I mean standard form. That's the best one. The other forms that we've learned are point slope and slope intercept. But when you're working elimination problems, standard form is the best form to have them in. And it's very important that you line up your variables. So see my x's right here. These are my x's and they're in 1. These are my y's and they're lined up, you know, with each other. And then these are my constants and they're all lined up. You can kind of see how each one is lined up. And remember, every number or term has a sign, and every sign has a number or term. So so basically what you're looking at here is two different equations, both in standard form, and we're going to try to eliminate one of the variables by, in this case, adding. And the reason why I say in this case adding, the first thing you're going to do after you've put them in the same form, that's step number 1, ensuring that both equations are in the same form. Step number 2 is then you're going to look at your variables and determine whether you're going to add or subtract. In this case, I'm going to add. And the reason why I'm going to do that is because this term right here has a negative and this term has a positive. So if I add a negative 3y with a positive 3y, then I know they're going to eliminate. That's how we get the name of elimination. So what I would do then is these are going to eliminate. So that's going to be 0. But I also have to add the rest. So I have to add my x's now. So 4x plus a negative 2x would give me 2x. I'm just going to stick a plus here. My 0, which we've already determined that they're eliminated. And here I have a 5 plus a negative 7. That's going to give me negative 2. So now I've eliminated one of my variables. That was my goal because I want to work to get one variable isolated. So now I can the next step is to solve. So the first step is to get them in the same form. The second step is to add or subtract in order to eliminate one of the variables. Then the third step is to do that adding and subtracting. And then the fourth step is to just solve it like it were a regular algebra problem. So here I've got 2x equals -2. I'm going to divide both sides by 2, and that gives me x equals -1. Now, just like we did in substitution in the last section, we're going to take this x equals -1 and substitute that into one of my equations from the first. And I'm just going to go ahead, since I'm kind of moving it up, I'm going to go ahead and plug in this -1 into this equation here. So I'll do -2 times, I'm substituting what my x value was in for my x. Oh, I've run out of paper. -2 times -1 is 2 plus 3y equals -7. I'm going to go back up here and erase this part and continue my problem there. I need to write smaller, maybe. That might help. Okay, so I'm just going to rewrite that last step down there so we can kind of see where I was. I was at 2 plus 3y equals -7. I'll subtract 2 from both sides, just like I've solved any other algebra problem. Bring down my 3y equals -9. Divide both sides by 3. And that's going to give me y equals -3. So my ordered pair is -1, -3. That is the ordered pair that solves this system of linear equations. And typically what you would do from here in order to make sure you have the right answer is to check it. But let me switch back over and see if you have any questions. Does that make sense? I'll try to write smaller so that it's all on one piece of, like, a little all together. Did that make sense to you? Okay. All right. Well, that was number 1. And we'll move on to number 2. Wish there was a way to highlight and delete. All righty. The next one is, well, goodness. Way to go, Miss Sparks. The next one is -5x minus 6y equals 8. And then that's the first equation. And then the second equation is a positive 5x plus 2y equals 4. All right. First thing we want to do is make sure that they're in the same form. And we really want them in standard form because that's the easiest one to work with when you're doing elimination. They're both in standard form, so we've got that done. The second thing we want to do is look at and decide whether we want to add or subtract here. And the way we do that is if we see two variables that share the same coefficient, and in this case, it's a -5 and a +5, so they're close to the same coefficient, this on the variable x. So because they have opposite signs but the same number, like the 5 is basically the same, but the signs are opposite, one's negative, one's positive, then we're going to do adding. And we'll move to this, but just kind of to give you a heads up, if the signs were the same, so like if they were both positive, that's when subtraction would come in, but we will eventually get to some of those sample problems. But here we see that the x's share the same number coefficient, but different signs. So we're going to use adding. So -5x plus a +5x, that's going to give us 0 here. -6y plus +2y is going to give us a -4y equals, and then we're adding an 8 and a 4. That is going to give us 12. So we've got -4y equals 12. We'll divide both sides by -4, and that's going to give us y equals -3. So now what we'll do is take this y equals -3, and we're going to substitute that into one of the two equations. So we'll do 5x plus 2 times -3, because we're substituting this y equals -3 in for the y on that second equation there. It doesn't matter which equation you use on this particular thing, on your elimination when you're substituting back in. Either one would work. So oftentimes if there's a difference in the ease, obviously pick the easier of the two, but there wasn't much difference on this one. So we have 5x, and then 2 times a -3 is -6 equals 4. Add 6 to both sides. Just begin solving. And those are going to cancel out, so that gives us 5x equals 10. Divide by 5, and that's x equals 2. So our ordered pair that is the solution for this system of linear equations is 2, -3. How you feeling about it so far? Okay, good. All right, let's move on to the next one. Do you have any questions? Are the examples helping? Okay, good. Have you watched the video yet? I know I just recently posted it, so it'll probably really come together for you if you get a chance to watch it. I don't know if you've had a chance yet or not. Okay. All of the steps that I'm talking about, making number one, making sure they're in the same form. Number two, checking whether you're going to add or subtract, then do the actual adding and subtracting. And then, solve and then substitute back in. All of those are written out in the video. So you'll have those for your notes. Just in case you feel like I'm moving a little too fast for that, they are written down step by step by step in the video. So you can write them down. So I'll move on to the next. I got that whole one on there. That did a little better on my writing. Okay, the next one is 6x minus 4y equals 14, and negative 3x plus 4y equals 1. Once again, just reminding you, making sure that your variables line up. My x's are on top of each other, my y's are on top of each other, and my constant are on top of each other. That's why standard form just works best for elimination. And how now that I'm making sure they're in standard form, making sure my variables line up on top of each other, the next thing I'm going to do is determine whether I'm going to add or subtract in this particular problem. I see that my y's have almost the same coefficient on them. They both have the 4. They do have the opposite signs, negative 4 and positive 4. So I'm going to choose to add in this case. And I'm going to add my y's. So I've got 6x plus a negative 3x. That's going to give me a 3x. My negative 4y added to my positive 4y is going to eliminate my y's in this particular case. So I would have 0 here. And now I have 14 plus 1, so that equals 15. So I have the problem 3x equals 15. And I'm going to solve by dividing both sides by 3. X equals 5. Now I'll use this x equals 5 to substitute back in to one of the two equations. And I'm just going to go ahead and use the bottom one. 3 times 5 plus 4y equals 1. Negative 3 times 5 is negative 15 plus 4y equals 1. I'm going to add 15 to both sides, and that's going to give me 4y equals 16. And then I'm going to divide both sides by 4, and y equals 4. So my ordered pair that solves this system of linear equations is 5, 4. That was number 3 for the guided practice. Oh, I see that you answered it. Good job. It is 5-4. Did you get it done long before I did? I know you're fast. Okay. Well, good. I'm so proud of you. That means that it's coming together. Oh, I'm so stoked. Yay. All right. Moving right along. We're going to do number 4 together for the guided practice. And there's one problem in the video. So you're just almost done with math for the day, Miss Campbell Smith. All right. Number 4, 7x minus 2y equals 5. 7x minus 3y equals 4. First thing we're going to do is check to make sure they're in standard form, and both of them are. So that's good. We don't have to change anything. The next thing we're going to do is look to see if we have a variable that has close to the same number, but perhaps opposite signs. But in this case, they actually have the same exact number and not opposite signs. So that's on the x, and they're both a positive 7x. So in this case, instead of adding, we're going to subtract. Now that can get complicated a little bit just because we're going to be changing some things. So let me, so we're going to subtract. And when you subtract, that means you're basically going to, like, way back in the day when we first began to be adding positive and negative numbers, what we would do was do that keep flip change. So if we're subtracting, then essentially what we're going to do is go through and change all of the signs and then change this back to addition, but we have to change every sign. So that's kind of what you're doing. Does that make sense? That's that whole keep flip change thing. I'm going to go back. Okay. That does make sense for you? Okay, good. So now we have opposite signs. So we can go back to solving. So it's kind of like adding at this point. So 7x plus a negative 7x is going to give us 0. We have a negative 2y plus 3y is going to give us a y equals, and then we've got a 5 plus a negative 4. So that's going to give us 1. So our y equals 1. So we're going to plug in this 1 into one of the two equations. At this point, I'm just going to pick the top one. 7x minus 2 times 1, because we're substituting the value 1 in for our y. So 7x minus 2 equals 5. Now we'll add 2 to both sides. And we get 7x equals 7. And now we're going to divide both sides by 7. And that gives us 1. So our ordered pair is 1, 1. That's the ordered pair that solves this. Yes, you got it right. Way to go, Campbell. You're so smart. Um, all right, so I'm going to erase this, and we're moving right along to number 5. I don't know if you're following along in the book or if you're writing the equations down as I write them down. But I was looking ahead a little bit, and I was noticing on this next one, we're going to have to change our form. So on this one, we have 3x plus 4y equals -6. And then we have 2y equals 3x plus 6. Now, these are not in the same form. And like I stated, standard form is the best way to solve when doing elimination problems. So we need to change this second equation into standard form. And how we would do that is to get our x on the same side as our y. So we are going to subtract 3x from both sides of that equation, which then will give us -3x plus 2y equals 6. And so that they're lined up on top of each other, I'm going to go ahead and bring down this equation down here so they can line up so we can do the elimination part. 3x plus 4y equals -6. Now on this, you'll notice what the first thing we want to do, we got them in the same form. So that's the first step, getting them in the same form. That second step that we're going to do is we're looking for the variable that has the same, roughly the same coefficient, which is this -3 and 3. The number part is the same, but the sign is different, but that's okay because when the sign is different, we're going to choose to add to eliminate that variable. So we've got -3x plus a +3x. That will eliminate the x's. So that'll give us 0 there. We've got 2y plus 4y. That's going to give us 6y. And then we've got 6 plus a -6. So that gives us 0. And y, and then we divide both sides. Oops, my bad. Divide both sides by 6. And that gives us y equals 0. And then we'll take that and plug that 0 back into one of our equations. I'm just going to use the bottom one. 3x plus 4 times 0 equals -6. 3x plus 0 equals -6. 3x equals -6. Divide both sides by 3. X equals -2. So my ordered pair that is the solution for this problem is -2, 0. Oh, do you see where I get, did I do something wrong? Because I see where you said it was -2, 1. What did I do wrong? Oh, okay. All right. I was like, okay, let me go back over my work because you're pretty sharp. You could, teacher's not always right. We make mistakes. Okay. So that's, and the other thing we can do, this is always a good thing to, definitely stick them back in to see if it works. So if you put a -2 in to this problem, right, into one of the equations and a 0 and see if it works out. And it does for both of them. It works out. So, all right, let's go back. Well, that was number 5. Yay. So we're getting ready to do number 6 unless you have a question. Do you have a question? Okay. All right. I'm going to go to do number 6 now. I'm glad you showed up for math lab. Makes the time go by faster when I get to work with somebody. Makes it more fun. Okay. The last one is 2x plus 5y equals 12. And then 5y equals 4x plus 6. So our first step is to check and see if the equations are in the same form. In this case, they are not in the same form. So we have to change that second one to put it in standard form. So in order to do that, you would subtract 4x from both sides. And that's going to give you negative 4x plus 5y equals 6. So just to kind of keep it neater, I'm going to go ahead and bring this equation down so it can line up underneath. So I've got 2x plus 5y equals 12. All right, in this case, my y's have the closest, where the coefficients are closest to being the same. Well, actually, they're exactly the same. We've got a positive 5y and a positive 5y. So that means since my coefficients are exactly the same, not only is the number itself, the digit itself the same, but the signs are the same, then I'm going to choose to subtract. And in so doing, I'm going to change that to a minus, which what that does is I go through and I change every single one of my signs and change it to an addition. So I would change this positive 2x to a minus. I change this positive 5y to a minus. And I change this positive 12 to a minus. And then that just changes it to a plus. Once I've gotten each one of my digits changed, the sign changed, I can change it to an addition problem now. So I've got a negative 4x plus a negative 2x, which gives me a negative 6x. And then I've got a positive 5y plus a negative 5y. That's going to cancel each other out, which was the whole thing we were hoping for, because that's why it's called elimination. You're trying to eliminate one of the two variables, so you can just work with substitution. And then 6 plus a negative 12 is going to give me a negative 12. Now I'm going to divide both sides by negative 6. And that's going to give me x equals 2. Because a negative 12 divided by a negative 6 is a positive 2. Now I'll take that positive 2 for my x and I'll substitute it back into one of the equations. And I'm just going to use the bottom equation. In its original form. Or actually, I think I'll just use the top so that I don't confuse you by going back to the original form. So I'll just use the top one since we didn't change it in any way. -4 times 2 plus 5y equals 6. So I've got a -8 plus 5y equals 6. And then I'm going to add 8. What did I do wrong? Did I do anything wrong? Let me go back. Oh, thank you. You're right. I was like, I knew I did something wrong when I got to this part. Bless you. I don't know why I wrote -12. It is -6. I knew when I got there, I was like, oh, I did something wrong when it worked out like that. Bless you. It's 1. I think I'm good now. Okay, now I'm going to add 4 to both sides. And it's going to give me 5y equals 10. And then divide both sides by 5, and it's y equals 2. So the ordered pair, after all of that, was 1, 2. Thanks for catching it. So did you end up with the same thing? Okay, good. So that's all of them. That's all the guided practice problems. How do you feel about elimination? Oh, hey, no problem. No problem at all. And like I say, the video is only about 9 minutes and it has one little sample problem. Yeah, I was going to say, it sounds to me like everything, or like when we were working them together, I think you did 4 of them by yourself technically, and then just checked your answers. You were even able to catch my math mistake. So I feel like you did great. The video, I think, will just kind of straighten out like where you can write down the actual steps, step by step by step, because they're written out for you. So that'll be good, because it's always nice just to have those right in front of you to work the problems. It's not bad though, and I hope you get to feeling better. Do you think you'll be there tomorrow, unless it snows? Okay. Well, you have a blessed afternoon and continue healing, okay? All right. Take care. Bye-bye.